Good afternoon.
Afternoon.
Okay. Today we gathered for the defense of the dissertation by Syrgabek Yerkanat on the topic development of methods for the determination of pesticides in grapes using solid phase microextraction. Specialty 6D05301 chemistry. Scientific supervisors Miriki Alimjanova, candidate of chemical sciences, PhD, associated professor, head of the Biosphere Ecology Laboratory at Center of Physical Chemical Methods of Research and Analysis, Faculty of Physics and Technology, Department of Thermal Physics and Technical Physics of the Al-Farabi Kazakh National University. And foreign supervisor Pedro Antonio Garcia Encina, professor of the Department of Chemical Engineering and Environmental Technology and head of the Research Institute of Sustainable Processes of the University of Valladolid from Spain. The dissertation was performed at the Department of Analytical Colloid Chemistry and Technology of Rare Elements of the Al-Farabi Kazakh National University. Official reviewers, Marek Tabizevsky, PhD, Associated Professor, Gdansk University of Technology, Chemical Faculty, Department of Analytical Chemistry, Poland, and Maria Lumpart, Professor, Center for Interdisciplinary Research in Environmental Technologies, Santiago de Compostela, Spain. And temporary members of the Dissertation Council, Petr Solik, Professor, Charles University Faculty of Pharmacy, Czech Republic, Daniel Snow, Professor, Research Professor at University of Nebraska, USA, and Thomas Dimersky, PhD, Department of Analytical Chemistry, Gdansk, Poland. The floor is given to the Scientific Secretary, Professor Bulat Uralbekov, to present the documents available in the applicant's personal file. Please.
Yeah, thank you, Chairperson. Dear colleagues, just brief information about applicant. Yeah, it's Syrgabek Yerkanat Arghanullah, born in 1996. First, his undergraduate studies at Al-Farabi Kazakh National University from 2014 to 2018 at Faculty of Chemistry and Chemical Technology, majoring chemical technology of organic substances. In 2018, he enrolled to master program at Al-Farabi University, majoring chemistry, and successfully completed his studies in 2020. From September 2020 to May 2023, Syrgabek Yerkanat pursued his PhD at Faculty of Chemistry and Chemical Technology of Kazakh National University, specializing chemistry. Topic of his dissertation and his advisor were approved by Academic Council of our university on June 14, 2023. Here we have his copies of his bachelor and master diplomas, list of publications, the recommendation letters from scientific advisors, the documents like a protocol of enlarged meeting of department, and all other required documents in accordance with the regulation of Committee for Assurance, Quality Assurance and Science Education of Republic of Kazakhstan. As a part of his dissertation work, candidate published 4 works, including four papers, including 3 papers in Q1 journal and 1 paper in Q2 journal, indexed in Science, in the Web of Science. Yeah, indexed in Science Citation Index Expanded Web of Science, and also he has several abstracts presented in international scientific conference. This year, on September 24, his dissertation was discussed at the expanded meeting of Department of Analytical and Colloidal Chemistry and Technology of Rare Elements. This meeting, 55 participants attended. The first reviewer, Professor Uralbekov, the professor of Department of General Chemistry. And the second reviewer was Madi Baltabayevich Abiliev. All questions and comments raised by reviewers were responded, and the academic seminar recommended the dissertation for further defense. By protocol number 47, October 17, and protocol number 46, the dissertation council scheduled defense date, they appointed official reviewers and also temporary council members. I also want to give you some information about our regulation. During the thesis, during the defense, the dissertation council will conduct secret ballot to make one of the three available decision. The first one is to award the degree of Doctor of Philosophy, and the second one to recommend a repeated defense of the dissertation, and also the final one is deny the awarding of PhD degree. The dissertation does not, if the dissertation does not fully comply the rules for rule 6 of the degree awarding rules, and partially adheres the principle outlined in clauses 5, it's recommended for repeated defense. If there is some violation of academic integrity or non-compliance with principle of scientific novelty, internal consistency, reliability, decision to deny the degree should be made. So also what I want to mention, that official reviewers will also participate in this secret ballot, and their votes have the same weight as the votes of dissertation council members. That's why please be until the end of defense, because the reviewers will also vote. And the agenda for today defense is we will give 20 minutes for candidate to present main results, and after that we will have a session for question. Please, the reviewers also can ask questions during this, and after that the advisors will take a talk, and after this reviewers, the official reviewers will introduce their review, and after the discussion, we will have a secret ballot, secret vote. Okay, that's all information I have.
Are there any questions for the scientific secretary?
One moment. I want to also mention that there is no thesis. The candidate will defend his thesis as a series of papers, and also that means that we need to evaluate the abstract available and also papers published by the candidate. Thank you.
Thank you. The floor is given to the applicant to present the content of the dissertation. Yerkanat, you have 20 minutes. Okay.
You hear me? So let me start. Good morning, dear teachers, professors, and members of the dissertation committees. Today I'm pleased to present my PhD thesis titled Development of Methods for Determination of Pesticides in Grapes using Solid Phase Microextraction. To the beginning of this dissertation, I would like to talk about topic is why important. Grapes are one of the most important fruits in the worldwide. And in the figure 1, you can see that their global production has steadily increased over the past decade. This growth highlights their economic importance, but also raises the concerns about higher production often leads increased or the pesticide application, which may impact both consumers and environment. A similar trend is observed in Kazakhstan in the picture number 2, where the grape production is also rising. However, when comparing pesticide regulations, significant differences appear. Here, the European Union maintains of the strict control our pesticides MRL, but in contrast in Kazakhstan, several pesticides are until not regulated, which creates potential risks. So additionally, many existing methodologies for pesticide determination at time-consuming and rely on toxic reagents and making routine monitoring difficult. And altogether these points relevance of the development of greener and eco-friendly methodologies, reliable approaches to pesticide determination in grapes. For purpose of the studies, development of eco-friendly methods for analysis of pesticides in grape samples based on solid phase microextraction. Subject of the studies is 11 pesticides and object of the studies grape samples. So solid phase microextraction coupled with gas chromatography and mass spectrometry has been chosen as main research method. And also in the picture, you can see the main step of the sampling and sample preparation with instrumentation. The main provisions to be defended, the optimal parameters for vacuum SPME for the determination of pesticides, 6 pesticides with GCMS are follows: extraction temperature 17 degrees, extraction time 40 minutes, option fiber based on polyethylene glycol, sample volume 1 milliliter, vacuuming time 60 seconds, pumping rate with 170 liters per minute, pH at 10, and require for the limit of detection and limit of quantifications. And also the optimal parameters for solid phase microextraction, miniaturized SPME for the determination of 11 pesticides with GCMS are follows: extraction temperature 19 degrees, extraction time 40 minutes, 30 minutes, pre-incubation time 10 minutes, option fiber based on PDMS, sample volume 200 microliter with salt addition, pH at 6. And also analytical performance of established. And third one is the scores of calculated using tools, AgriPrep and Baggy tools for the vacuum SPME based 0.67 and 60 points. And for the miniaturized SPME, they were 0.79 and 67 point respectively. And for implementation of this work, we chosen task number 1 to perform comparative analysis of modern analytical methods for determination of pesticides in grape samples using GAPI tool. And next one is to optimize parameters of VAC SPME for pesticides in grapes and establish their analytical performance. Also to optimize the parameters of miniaturized SPME for pesticides in grapes and also establishing of the analytical performance. And last one is to evaluate of the proposed vacuum and miniaturized SPME methods using GAPI, AgriPrep, and Baggy tools. As task number 1, you can see the summary of the modern analytical methods used to pesticide analysis. The process generally includes the sample preparation, separation, and detection methods. For sample preparation, the most common techniques use cultures and SPE, solid phase extraction. For separation, liquid chromatography and gas chromatography used. And for detection, tandem mass spectrometry and mass spectrometry used due to reliable identification even at the trace levels. And this combination, effective extraction of the chromatograph separation and selective detection forms a reliable basis of pesticide monitoring in grapes. And according to the literature review, cultures combined liquid chromatography mass spectrometry used about 50 or 25 and 60% the published methods. The second most widely used group, it includes solid phase extraction and solid phase microextraction with gas chromatography. And this confirmed that SPME-based approach are gaining attention and green alternatives. These slides present the 10 principles of green sample preparation. The main idea is to reduce environmental impact by using in situ preparation, choosing safer solvent, minimizing chemical use and waste, and selecting renewable materials. And also you can see the modern tools to evaluate the greenness of sample preparation and separation methods. It includes of NAMI, Agree Prep, and BAGI. In our works, we use the Green Analytical Procedure Index due to comprehensive assessment of the sample preparation to instrumentation. And GAPI tools includes assessing of the general method type, also sample collection, sample preparation, reagents, and instrumentation steps. Using GAPI tools, we evaluated 43 published methods for pesticide analysis in grapes. As a result, traditional solid phase extraction solvent-intensive techniques received lower greenness scores. In contrast, solid phase microextraction with gas chromatography or two-dimensional gas chromatographies approach achieved a significantly higher greenness due to reduced solvent consumption and simplified workflows. And therefore, this clear need to greener methods to according to the green analytical chemistry principles to prefer the approach according to green analytical chemistry, solvent-free or low solvent techniques and miniaturized techniques. And base task number 1, and as a result, we review studies were published in Foods Journal and also another research published Trends in Environmental Analytical Chemistry. Next step, we focus to developing of vacuum SPME methods approach. This method, originally proposed by Eli Apsilakis, is based on classical SPME, but vacuum valve is used to reduce pressure inside NVL. Two types of valve, stainless steel and Teflon, were tested in our works, and also commercially available vials and fibers were used as well. And incubation and extraction processes will happen before the GCMS analysis. Here you can see the comparison of the signal intensities. Vacuum SPME provides significantly higher responses for all target pesticides, often double more achieved with the classical SPME, illustrating the effectiveness of the vacuum solid phase microextraction. And in our work, we compared 3 commercial fibers, the UV-Car PDMS, PEG, and PDMS. The PEG fibers demonstrated the highest response for all target pesticides, especially for oxyfluorphan, fluroxypyr, and epoxyconazole due to its more polar and more affinity with our fibers. And PEG was selected as the optimal fiber for further our improvements. A next step of optimization is vacuum, and we tested the 3 profiles. On the left, you can see the results of metribuzin, oxyfluorphan, and fluroxypyr-methyl. The highest response of the oxyfluorphan and fluroxypyr were obtained at the 60 minutes. Extending of the vacuum to 120 minutes didn't improve the signals because the seconds didn't improve significantly, and because it vial already was evacuated, and metribuzin showed the very low responses all the time. And another epoxyconazole, Kuzilafop, and Baskelit also extending of the time didn't improving our extraction efficiency. Based on this result, we selected 60 seconds for optimal vacuum time. And to find the optimal extraction temperature with PEG fiber, we tested also 3 profiles at 30 minutes, 30 degrees, all the signals very low, and 50 degrees responses increased slightly. And the best performance was achieved at the 70 degrees. According to SPME theory, the higher temperature increases of the analytic diffusion coefficient, which improve the mass transfer to fiber coatings. In addition of the heating samples under reduced pressure further also enhanced our extraction efficiency. And based on this result, we selected 70 degrees as optimal temperature. Next, in this part, we optimize the extraction time. The graphs compare the signal responses of the 50 and the 70s, all target pesticides. At the 50th degree, the response of the are low and increase only slightly over the time. At the 70th degree, extraction is much more efficient, and most compounds of reach a stable plateau between the 30 and the 40 minutes. It's important to note that highly hydrophobic pesticides may require the longer times to reach equilibrium. For example, oxyfluorphan, fluroxypyr show their highest responses around 40 minutes. So based on these results and balance between the sensitivity and efficiency of our methods, we choose 40 minutes as optimal extraction time. Next, we optimized the volumes of the ranging from the 0.25 to 5 milliliters. In the picture, you can see the results of metribuzin, oxyfluorphen, and fluoroxypyrimethyl. The strongest response appeared for the oxyfluorphen and reached its maximum only 1 milliliters. And also for all target pesticides, these patterns observed. And beyond this, increasing our sample volume to 5 milliliters didn't provide of additional improvement. For this one, volumes 1 milliliters chosen as optimal. And we also examined of the effect of sodium chloride as shown in the table on the graph. The addition of the sodium chloride didn't significantly enhance the extraction of the pesticide studied. When we look at the relative standard deviation of 4 replicates, we see the values for all target pesticides within the acceptable errors. And based on these results, we can conclude the salt addition doesn't improve extraction efficiency in the vacuum SPME method. And also, we evaluated the effect of pH and the 3 profiles, 3, 6, and 10. These results are shown the 2 groups of analytes, and also high pH values improve of extraction for basic compounds, and oxyfluorphen showed a particularly strong increase. And acidic and neutral pH, the signals were much lower. For example, epoxyconazole reached highest signals at the pH 10, and also quizilafop and bascalit also showed a moderate improvement under alkaline conditions. And due to its results, we selected pH at 10 as the optimal condition for further experiments. This slide summarizes analytical performance of the optimized vacuum SPME GCMS method. We first evaluated of mini-art vacuum valve, where the detection limits ranged from 100 to 600 nanogram per milliliters. These values were relatively poor because the valve didn't maintain the stable vacuum inside of the wheel. We then tested the new SPME VAC SPME Aero valve, which provided much better performance. The detection limits improved between 0.02 and 1.3 nanogram per milliliters, and approximation coefficient were also strong. Also, this method demonstrates significantly better analytical performance when using the SPME Aero valve. And the next slide, we prove this efficiency of optimized parameters for real samples analysis performed using the developed method. The table compares the pesticide concentration detecting on several grape variants with the maximum residue limits established in Kazakhstan in the European Union. For most pesticides, concentration were below the detection limits, and only compound detector fluoroxypyr in the kishmish between variety 0.40 microgram per kilograms. This value is below European Union limits of 0.2 microgram per kilograms, which means the sample meets current food safety requirements. And these findings confirm that developed methods is stable for real samples analysis and provides a reliable monitoring of pesticides in grapes. And according to this result, task number 2, findings our developed method vacuum SPME GCMS has been published in Advanced in Sample Preparation Journal. Our next step is optimization of the focus to miniaturized solid phase microextraction combined with gas chromatography. We take the very small amount of sample and place in the wheel, and also this wheel are heated. After that, incubation solid phase microextraction processes will happen before the GCMS analysis. And after fiber is transferred to direct GCMS systems, 4 compounds are desorbed and analyzed. And also in these methods, we compare the 5 different coatings: PDMS, PEG, DVB, CAR, PDMS, and polyacrylate, and PDMS, DVB. Among these options, the PDMS fiber provided strongest overall response for all target pesticides and simultaneous extractions. And the signals for compounds such as atrazine, simazine, and metribuzin were especially high with PDMS fibers. And we selected PDMS 10 for efficient extraction simultaneous 10 pesticides from the grape. Another important parameters, we examined the sample volume, and the miniaturized solid phase microextraction is crucial. These results showed that the best sensitivity was achieved at 200 microliters at a very small volume compared with conventional extraction techniques. At 100 microliters, the signals were unstable, but in the 30 or 300 microliters, there was no meaningful improvement. Based on this comparison, 200 of microliters was selected to optimal sample volume. In this slide, we optimized the extraction temperature and tested a wide range from about 30 to 110 degrees across the all plots. We can see that increasing of temperature generally improves analyte transfer into the headspace, which consistent with the SPME theory. In plot A, most pesticides reached equilibrium of 90 degrees. In plot C, some compounds such as metribuzin and simazine reached equilibrium around 70 degrees. And also in plot D, you can see the simazine, cyanazine, cosilaforp, and bascalit can be low signals. It's due to its properties. And also for simultaneous extraction for all target 10 pesticides, we choose as optimal temperatures as 90 degrees. And in this slide, you can see the evaluation of the incubation time and extraction time. The incubation time was tested across the full range of the shown in the figure. The results indicate that 10 minutes with the 30 minutes of the extraction provides the best balance between sensitivity and reproducibility. And this combination of the selected as optimal for this timing of the methods. We also examined the effects of salt addition and pH, testing at the pH levels 3, 6, and 10. The results showed that best performance was achieved at the pH at 6 with a moderate amount of the salt. Under these conditions, the extraction efficiency increased. All pesticides transferred more effectively into from the sample to headspace. And the behavior relates to the chemical properties of analytes. Many of the pesticides are weakly acids or basic, and the pH 6, they remain of the more neutral form, and which increases their volatility and improves the improvement into the headspace. Also, for miniaturized solid phase microextraction with GCMS methods, we did it on the analytical performance. The linear range generally from the 5 to 1000 nanogram per milliliter. Only cyanazine, epoxiconazole, oxyzilafop, and bascalit, which start 50 nanogram per milliliters. For detection limits, it was between the between 0.05 to 3 nanogram per milliliters, and limit of quantification were from 0.2 for 10 nanogram per milliliters. These slides present the validation of results miniaturized solid phase microextraction with GCMS method applied of the grape samples. We tested 5 grape matrices and spiked them at the 3 levels. In this case, measured concentration was slightly lower than the added amounts, but they remained consistent across matrices. And precision results also evaluated by intraday and interday precisions, and ranged from 2 and 50%. At the lowest spike levels, recoveries of the around 70%, and the higher concentration they reached about 98%. It is confirmed that the method is reliable for analyzing pesticides from grape samples. And also in this slide, we compare maximum residue limits established by Kazakhstan and the European Union with pesticide levels found in Greece of 3 grape varieties: Lady's Fingers, Shine Muscat, and Hussein. For all pesticides tested of the concentration of the grape samples below the detection limits. And this means that the residues were detected in any of the varieties, and all results remained below on the regulatory limits established by Kazakhstan and European Union. This slide compares the greenness performance of 3 approaches. First of all, classical SPME, next vacuum SPME, and miniaturized SPME combined with gas chromatography mass spectrometry. From the analytical perspective of miniaturized solid phase microextractions, offer of the linear range between the from 5 to 1000 nanogram per milliliters, and reach detection limits at 0.09 nanogram per milliliters. It also only 1 or 200 micrograms used for as sample volumes, and also short extraction times as 30 minutes. And regarding to sustainability, the GAPI pictograms show the red zones for all approaches, but miniaturized SPME displays the most balanced overall profile. And agree prep scores is highest for miniaturized SPME also as 0.79 compared with vacuum SPME, and the buggy evaluation also support this with the miniaturized solid phase micro extraction with reaching 67.5, which is higher than all other two methods. So miniaturized solid phase micro extraction and vacuum solid phase micro extraction provides better analytical sensitivity, requires much smaller and sample volumes, and outperforms of the greenness and sustainability our methods. As a result of the task numbers 3 and 4 this research article was published in journal Separation Science. In conclusion, for the first time, optimal parameters for determination of 6 pesticide with vacuum SPME combined with GCMS was established, and also analytical performance establishing, and also greenness calculated. And for the second one, for the first time, optimal parameters for the determination of 11 pesticides in miniaturized solid phase micro extraction combined with GCMS also optimized, and greenness and analytical performance also established. The greenness calculated using by AgriPrep and the buggy tools for the VAC SPME was 0.67 and the 60 points, and for miniaturized with GCMS it was 0.79 and the 67 and the 5 points. And also this works published in the international publication indexed in Scopus and Web of Science. And also scientific work funded by the grant funding programs of the Ministry of Higher Education and Science, and internship performed at the University of Valladolid under supervision of Professor Pedro Antonio Garcia. In addition, of the research results have been acknowledged at the multiple international conference, such as Food Biotech International Conference, International Symposium on Advanced Instruction Technologies, and also International Symposium of Chromatography, which supported by Chromatography Society and the Ministry of Science and Higher Education of Republic of Kazakhstan. And also, last conference was in the European Conference on Analytical Chemistry, which had presented oral presentation. Thank you for your attention, and I am open to your questions.
Thank you, Yerkanat. The presentation is complete. And are there any questions? Dear colleagues,
Can I have one question?
Kanat.
yes, please.
Yerkanat, thank you for your presentation. Can you show the slide number 17? Okay. Yeah, for both Khalid, at the after extraction time of 10 minutes, you have almost zero response. Yeah, but then after 40 minutes, you have some very high signal, like 13 or something. So how can you explain such results? So in the beginning, it's not extracted, but then at one moment extraction starts. So what's the reason of this delay, or what happens there?
Thank you for your question, Vlad Nurlanovic. For the first reason is, when we conducted these experiments, we did it without steering, and as you know, according to solid phase micro extraction, the steering can enhance our extraction kinetics. But in this case, we didn't use all the steering. It's maybe the first reason. It's for the first time it didn't extract it, and after that, after 40 minutes, it's extracted to the fibers. And the next reason it's for physical properties of the physical chemical properties of our analytes, our pesticides, and the bascalit also show highest of the QOW amount, which means that it's a more hydrophobic pesticide since it requires a long time and temperature for equilibration for the
Okay,
extraction.
but thank you. But maybe the pre-incubation time was not sufficient. Maybe you should increase it to like 15 minutes or like 5 minutes is really low pre-incubation time. Maybe you can increase it, and then it will be better.
Yes, we did this experiment with incubation time, but we didn't include for presentation because with incubation time we identified that our all for target pesticides responses are very low because it's experiments we conducted with miniart valve. And after that, we conclude that doing this experiment without incubation, but with longer extraction times and temperature.
Okay, thank you. But I have another question about the like limitation of the methods which are developed by you. What do you think are the main limitations of these methods?
For vacuum solid phase microextraction, is first limitation is we can analyze only semi-volatile compounds with gas chromatography mass spectrometry, and also vacuum valves is used for these experiments and for vacuum SPME. And the vacuum valves didn't maintain the stable vacuum in the inside of the wheel. Instead of, we can use another valve, a stainless steel valve. And also one limitation is for these methods, we should study, especially our staff, for doing these experiments. It's not easy.
Okay, but what about matrix effects?
Matrix effects also existing in these methods. It is also big, I would say, big limitations or issues, but we can reduce these matrix effects by using different calibration methods, such as matrix matched calibration and internal standards addition calibration and something like this. It depends what matrix we used.
But did you try to control somehow matrix effect during your research?
We did this experiment with the different grape types, and also we didn't control fully, but our recoveries from grape matrices was the medium between the 17 and 90%. It's suitable for many other approaches.
Okay, but what calibration approach do you use for your methods?
External calibration we used in this method.
Okay, but do you use like distilled water solutions, or you have some matrix in the calibration standard?
For preliminary experiments, we used water for just establish our standard compounds in the identification by gas chromatography for retention times, and all after the experiments was conducted in grape juice, only in grape juice.
No, I'm asking about calibration. So when you obtain the external standard calibration, do you use standards which are prepared in distilled water, or standards prepare using the grape?
Standard prepared with grape.
Okay, so you use matrix matched external standard calibration, yeah?
Yes. And
Okay. But did you try to obtain the calibration plots for different grapes?
as I mentioned before, that's only one type of the grapes. We obtained our calibration curve, but we didn't do this in other type of the grapes variates, and we didn't compare each others. Only one grape juice.
Okay. Okay, thank you. That's all from me.
Thank you. Are there any questions, dear colleagues? Да. Нет.
Hello,
Hello.
I have a couple of questions or comments.
Okay.
First
Please.
of all, I would like to congratulate Yerkanat for the very good thesis and for the very good presentation. But one of my questions is regarding the units of the limits of detection. Why do you express the limits in nanogram, milliliter, instead of a nanogram, gram? Because if you attend the maximum residual limits, they are referred in kilograms, nor in liquid form. So I think because you are working with grapes, you should refer the limits in grams or kilograms, but not in milliliters.
Thank you. Thank you for the question, Professor Maria Jompert. And regarding your questions, I would like to ask as all our calibration course, we did it in nanogram per milliliters, but when we calculated 2 microgram, 2 kilograms for our each detecting pesticides in grapes. For example, as I mentioned before, we find all the fluroxypyr in one grape samples. It was ranged between our calibration curve, but when we calculated it, 2 microgram, 2 kilograms.
Okay. In this case, you should express this limit in both units.
Yes, yes. We calculated in nanogram per milliliters and microgram per kilograms.
And my other question that Professor Kenesov talked about this, I would like to see the calibration curves in your presentation also, because here today you have you didn't show these calibration curves. Even if you are using matrix match calibration, it would be very good to show this calibration curves and to compare the slopes. Because you are saying that you were working only with one type of grapes, but when you calculate recoveries, the results were quite different, between 60% and 100, close to 100%. So probably you could perform the calibration in different grapes and show us the difference.
Thank you for the questions and the comments. Yes, we have a calibration course for all pesticides, but we didn't include in presentation, but in supplementary materials, I can show by requesting. And for further works in the future, yes, it's also most important question that the comparison of calibration curves and slopes between different grapes samples.
And even sometimes it's interesting to compare with water and see
Yes.
what's the difference. Because many
Mhm.
times, diluting the samples, you can get better results. So I would like to see that.
I got you. I got you. Thank you. Yes, we will include in the next.
For your reply. Thanks. And
Thank
congratulations.
you.
Thank you.
Dear colleagues, it's time to question. If Professor Sola, Professor Dan, Snow, Daniel Snow, if you have questions, just ask. Because now session for question.
Yes, I have a couple of questions. Very nice presentation, and the speaker should be commended for the getting their publications out before the defense. That's great. One question was, had you done any kind of a survey or evaluated pesticide use on grapes in Kazakhstan in particular? And if you did, how did the list of pesticides that you were able to measure compare with that list?
Thank you for the question, Professor Daniel Snow. And yes, we did it in our literature review. We compared it in the finding and searching of the different pesticides list used in the main traditional extraction techniques, such as cultures, solid phase extractions, and also sometimes of the solid phase micro extractions. And also we compared European Union pesticides used and also in Kazakhstan. But we found that in Kazakhstan, a lot of pesticides used for grapes, but not controlled.
So do you have an idea which pesticides you're not able to measure that are widely used? I think that's more specifically what I was getting at.
For our studies, as I mentioned before, we studied only limited of our pesticides, but the different properties with pesticides, but also in the future work, we can use the pesticides with same properties our studied, and also can predict and optimize to some matrices. And for regarding your questions, which type of the pesticides we didn't use, and maybe a lot of herbicides, this work.
Okay, and then the other question has to do with the greenness evaluation. I think that's a great topic to investigate and when you're developing an analytical method. Are there ways to make this method even greener? Any modifications that you might make that would make this even easier to use and perhaps use less harmful solvents?
In our developed methods, first of all, it's solventless methods for our optimized. Also, vacuum SPME and miniaturized SPME is solventless, and also with a good limit of detections and limit of quantifications, and also precisions. And for greenness, we compare it to the different greenness tools for evaluation of and other aspects for detailing evaluation, because regarding of the green analytical procedure index, it's evaluate only qualitatively, and for agree and agree prep, it's we can see some of the scores that greenness or not greenness, and this is main reasons we compare different greenness tools.
But was there any way to make your method even less, what is it, less hazardous?
For miniaturized solid phase micro extraction, it's less hazardous. We used only 200 microliters sample volume. It scores very well by agree prep tools and also shorten our extraction time. But in the vacuum SPME, we also didn't use any harmful solvents, but we used pumping rate, and it can be scores in the not very well.
Okay, that's all I have.
Thank you. Dear colleagues, do you have any questions?
Can I ask?
Please. Yes,
Okay.
yes.
Well, I have also some comments. First of all, thank you, the candidate, for the nice presentation. I very much admire. It was quite logical, short and logical. And my question is, you use the GCMS, but I notice in some slide that mostly is LC used, chromatography, chromatography used, not gas chromatography, like liquid chromatography. And very few in your review, very few times was used the UHPLC, ultra high performance liquid chromatography. Why you choose the GC? It's because of the pesticides and these compounds, or because of the instrumentation, or because, in my opinion, the LC liquid chromatography is more variable and it's more spread in laboratories. So what was the reason that you choose the GC?
Thank you for the question in the comments, Professor Piotr Zolich. And regarding for the question, first reason why we're choosing GCMS, because as most our analyzed pesticides are volatile or semi-volatiles, and GCMS, it's more suitable for analyzing this type of the analytes. And also regarding for GCMS, GCMS is most used and spread maybe in Kazakhstan and also in other countries, and also it more cheaper than UHPLC methods.
That's correct.
And yes, HPLC it's more expensive, and most of the researchers didn't buy these instruments.
Yeah, okay. I have another comment. The comment I notice you also mentioned the practical significance, and that I very much admire, or very good. It's very good that you try to implement these methods and issue these methods to Kazakh Scientific Research Institute, because most of the research we do are just they finish in a good paper and that's all. And you was trying, or your supervisor trying to submit to the research institute for the certification. Is there already any result from this submission, as you mentioned, or because in my opinion this is something why we did do the research, especially research in your area for grapes, which are important to analyze. And why? What is the result? Is already the certification approved, or can you comment it?
Yes, thank you for the questions, and also about the implementation of our development methods for Institute of Kazakh Grapes Institutes. We implement our work, but now I have the project Jaz Ghalım, but between this project we will plan in the next year we now implement these certifications, but in the next year we will continue our works with the real samples and for the next year. And now we have preliminary approving our implementation
Okay, thank you.
by this institute. Thank you.
Thank you, Peter.
Yes, I also have a question, if possible. Because it's chemistry, and probably I will have some question on chemistry as well. Yeah, I have actually a lot of questions, but let's discuss major. Regarding the extraction time, you said that 40 minutes is optimal, but 40 minutes extraction time, do you think it's not time consuming, 40 minutes? I think that for my opinion, when we have solid phase micro extraction, the analytics wants to do it as fast as possible, but to wait 40 minutes, what we are waiting for? I mean, we are waiting for equilibrium, we are waiting for something else. Okay, this is the first question.
Okay, thank you for the question, Radish, for about your questions. First of all, with extraction time, we trying to achieve maximum extraction and the maximum response from our analytes, because in this case we used grapes, because the grapes existed different and other organic components such as sugars, phenolic compounds, and then others. And for this case, for trying to achieve best and the maximum response, we did it a long extraction times.
Yeah, okay, but we can wait it 2-3 days even, so we can
Yes.
we can achieve even better after 2-3 days. That's why. But my question was, do we need to, as you know, the extraction is like first of all, it's in dynamic range, and then you go to equilibrium range. And then my question is, do we need to wait for equilibrium, or it's not necessary? We can just be in the dynamic range. The
And
question clear or not clear?
yes, it's clear. In the relating with vacuum SPME, we didn't use, as I mentioned before, steering.
I mean, if the sorbent, not sorbent, but here have this how to say volcano in English. Volcano in English. Fiber. If fiber saturated.
Yes, also fiber can be saturated, and I would say,
do we need to wait while until fiber saturated or not?
No, we didn't need.
Okay, that's my question was probably after 2 minutes it will be enough. I mean, you will have calibration, but again, it's just a chemistry. Yeah. Okay. This was a question in pre-defense, but still questions. My another question arose when I compare the LOD and LOQ of two methods, vacuum and mini. As I understand, the mini is just you use a lower amount of fiber, yeah, as I understand. But what I noticed, they have comparable LOD and LOQ. But in vacuum, you use the fiber, another fiber, but in mini, it's why they are so comparable. So if you will see, my expectation is that you need to get better parameters for vacuum solid phase micro extraction in compared to mini. How you explain this phenomena? For instance, if you will compare LOD, it's 0.5 and 0.2.
Yes, I got you. It's two types of the methods. Two types of the different fibers. First of all, it's PEC, and the next one is a PDMS. And the PECs fiber it's most polar, and especially in the under vacuum, in the reduced inside of wheel under vacuum works very well. Only under vacuum. But in the regarding miniaturized solid phase micro extraction, without vacuums, we use the PDMS, and it's.
So you achieved these parameters just due to better fiber, as I understand.
First of all, yes.
From my opinion, it's quite something interesting and probably need to be to further study. Okay, the next question which I have, it's you said that salt addition also somehow some kind impact the signal. But do you have any idea the mechanism of salt effect? Why salt addition is somehow impact?
Yes, salt addition is also crucial parameters for the solid phase micro extraction because salt addition may occur salting out effect for our analytes, because salt is can be enhancing our extraction in the transferring our analytes from sample to headspace, after that to fiber.
Yeah, you just described, you didn't say the reason, mechanism. I mean, what is the chemistry behind? Yeah, what is the physics behind of this? Not just describing. And I want to have the mechanism, how the salt affect this. That's and then the probably final question which I have regarding your provision. Actually, this quite a good provision. My question regarding this provision is, for instance, it was in the previous defense when Dr. Bukhanov defended this. My question was the same. You said that you achieved LOD and LOQ. But my question, if I will change in gas chromatography, like I will use another gas, probably softer, or I will use another voltage of chromatography or something like this. If I will change, will it be possible to get better parameters or worse, let's say?
If you want to achieve the better parameters, maybe you should be used another good detectors such as QTOF or tandem mass spectrometry. But regarding GCMS, when you change some of the parameters, we didn't change or better results, but maybe results changed a little bit.
I remember from Bakek in the defense, she used the different voltage and different gas, flow gas, and so on. And it was possible to. That's my question. If you will change in chromatography system, will you achieve? Will you achieve another?
I guess we didn't be achieved because our main sample preparation is solid phase micro extraction only. Just.
From my opinion, you will, of course, but once again, because I'm not analytic, so that I will skip. But and the last question regarding slide number 33 or 31. The 31 first, and then 33. This technical just moments. I said 31 first. 31. 31. 31. Yeah, here. In slope, as I said, the last time you saw the slope really precisely. It's a 5 significant numbers. How you can explain this?
Yes, as I mentioned before, you also talked about significant numbers. But when we calculating the slope, these numbers we get from our Excel file, or maybe
you get from which? From what?
From Excel file.
From Excel file.
Yes.
It's not answer.
But changing these significant numbers, I guess it's not Meaningful, maybe.
Tell me the precision of the value. How it's depend on which parameters it will depend.
For precision?
И precision, точность. Как вот точность, от чего будет зависеть, от каких вещей? Ну, не от того, что Excel дал же, ведь, правильно?
Yes.
5 значащих цифр, 5 significant numbers. 5, it's a really precise, really precise. That's why I'm asking how you measure this precise or calculate it. And 33, 33, 33. 33. Okay. So here we have a maximum, this is a maximum, this is PDK actually, да? Yeah, maximum.
Maximum result levels.
Okay. So you had strict maximum result level for the last one, yeah?
Yes.
Usually love missile like this. Can you explain why this, what this compound has this strict value of MRL? Almost 10 times lower than mitrobuzin. No, almost, let's say.
Excuse me, for atrazine or
For the last one,
for Kuzilafop?
yeah, you have 10 times lower maximum residual limit than mitrobuzin.
Yes, but these maximum result levels established before. This,
The maximum residual limit show us a toxicity of the compound or not.
yes, it's also first reason is toxicity of Kuzilafop methyls. Yes, I didn't understand your questions. Sorry.
Yeah, I'm saying it's probably more toxic or something like this. If it's more toxic, can you say me as a chemist why it's more toxic?
For Kuzilafop methyl, it's maybe existing as different functional groups like the methyl. For first of all, it's toxic for our bodies, and also existing is benzoic circle in the function.
Okay, thank you.
Dear colleagues, do
May
you
I?
have any questions? Yeah.
Yeah, I have two short questions. First one is about the validation, because I have noticed that there is a certain concentration gap between limit of quantification and the lowest value in a linear range. So how would you perform? What would you do in case of obtaining the result between linear range and limit of quantification?
Thank you for the question, Professor Marek Tobiszowski. Your question is related with vacuum SPME. Yes,
I think so. Yeah.
Yes, this linear range and limit of quantification for using mini-R12 for first experiments doing with this valve, and limit of detection and also limit of quantification was above linear range, and it's was like this strange for us. And the next experiments we're doing with a new vacuum valve. It's a VAC SPME Aero. It is also stainless steel and maintain its stable vacuum inside of vials. And after doing this experiment, we achieved a good limit of detections below our linear range.
Okay, so you should perform validation within a single system without making any changes during the validation.
Yeah.
Yeah. My second question is about the publication of GAPI assessment. You have assessed really many analytical procedures, all for determination of pesticides in grapes. So can you summarize the main outcomes of this assessment? So what recommendations would you give us to create a green analytical method for determination of pesticides in grapes?
Mm-hmm.
So have you noticed any patterns or or something like that to make a certain recommendation for analytical chemists?
Okay, thank you for the questions. About the publishing, the last publishing about the GAPI, Green Analytical Procedure Index, it's we found that all sample preparations, not only separation and instrumentation methods, depends each others, because when we choose different methods, we should be mentioned that what we expect. If we want to more greener and sustainable methods, we should be choose more solventless sample preparation methods, and also with low sample volumes. And also instrumentations can be affect for overall scores and overall displays our GAPI pictograms. But in the Green Analytical Procedure Index, we have some limitations because it's only qualitative without scores. Yes, and our main suggestions, if it depends our analytes, we analyzed if we should achieve low limit of detections and a good performance and with good limit of quantification, we should be choose good instrumentation with basic traditional sample preparation, but without greenness.
Okay, yeah, thank you. Thank you for the explanations. They are quite typical, so this system is not very unusual. Okay, thank you.
Thank you.
Okay, thank you. And I have one question. We can see from your results, you optimized the several conditions, namely pH. Yeah. Why you used for vacuum methods pH equals to 9, and for mini pH equals 6. And do you research how change degree of ionization of pesticides and how its influences on viability or substance of pesticides?
Okay, thank you for your question, Ahmal Mohamedna. So first of all, regarding on this our development method, we didn't study it of especially ionization of any of the pesticides. We just use our instrumentation for measure our responses, but we didn't know what's happened in these solutions. But about the pH, for vacuum SPME pH at 10, it's most optimal because in the vacuum SPME we used only 6 target pesticides, and all 6 target pesticides basically weak basic, and also in the pH at 10, it's good for these solutions. And regarding for miniaturized SPME, we added another pesticides, more polar pesticides, as atrazine, simazine, metribuzin, and overall numbers of the pesticides increase. And the pH at 6 was optimal because in this pesticide we have also weak acids and weak basics.
And you only used only response, yeah?
Yes, we used only response from mass
Okay.
chromatography.
Okay, and the second questions, in the future, can we adapt your approaches on another objects? And what the parameters we will optimize?
Okay, thank you for your questions. Yes, these development methods can be used for another matrices like different berries, apple, maybe another berries. And for this reason, we should be properly optimized our independent variables such as extraction times and also, and well, main reason we should be optimized of matrix effect because matrix effect is very crucial for solid phase micro extractions. And also we can use another detection systems, another like not mass spectrometer, it's under mass spectrometer or much better, and achieve good results with different matrices. Thank you.
Thank you. Dear colleagues,
Yes, I have one question, if I can.
okay.
I just wonder, could you explain why, for example, the extraction experiments were conducted at selected fixed parameters like fixed temperatures instead of applying full design experiments to systematically optimize temperature, for example, together with the other extraction parameters. So additionally, maybe are there optimized parameters truly independent from the another one?
Thank you for your question, Professor Tomasz Mirsky. Regarding your questions, why we optimize only fixed temperatures and extraction times. First of all, we used design of experiments for identifying of the dependence and independence for our optimized variables. But we found that design of experiments didn't work very well, and we trying to use this type of methods starting from low point and increasing our optimized parameters and achieving the maximum response.
Okay, thank you. Just asking if you check this, so thank you.
In the future, we can also, yes, use.
Bulat Nurlanovich, please.
So I have one more question about the limit of detection for the slide 31, I think. So how can you please repeat how you determine the detection limits?
Thank you for your question. For limit of detection, I determined by using signal to noise ratio. For limit of detection, it means noise multiplying to 3 and dividing two signals. And for limit of quantification, it's 10 times more.
Okay, but what concentration did you use to determine the limit of detection?
For determining the limit of detection, we used very low concentration. It's first concentration.
Like 5 nanograms per milliliter?
Yes.
Yeah, but you know the difference is like 100 times. So it means that at this concentration, what was the signal to noise ratio at the 5 nanograms per milliliter?
Now, precisely numbers I forgot, but this is measured by this type only.
So it should be 300 actually, according to what you said.
Yes,
So
yes,
it's,
it's the 300.
Was it very large peak?
Yes, it's for some pesticides, it was very large.
Yeah, but you know that the difference is too large, like 2 orders of magnitude.
Yes,
Okay, but
yes.
is it theoretically possible to detect such amount of fluoroxypyr methyl? What is the sensitivity of detector?
Sensitivity of the detectors, it was established by this only GCMS instrumentation, but according to theory, yes, we achieve this concentration, but it's also in the practical we do it.
Okay, so if you extract 100% of this compound from the sample, what mass of this analyte will reach the detector?
If 100, please, can you repeat the question? Sorry.
Yeah, if you extract 100% of this analyte from the sample to the fiber, yeah, so what mass of this analyte will reach the detector?
Yes, so it was 100 mass of analytes. Will be.
No, what mass? What mass will reach the detector? Okay, what's the volume of the sample?
1 milliliters.
In this method, is it 1 milliliter?
We added only 1 milliliters of the same. No, it's a miniaturized only 200 microliters.
Okay, so what mass of this analyte is present in 100 microliters of the sample?
We should be calculated it and maybe approximately 140 microgram per kilograms. This I didn't forget.
So how to calculate this mass?
We should be used to the first grade mass and multiplying it to concentration of our analytes and dividing to 1000.
No, but it's you didn't take mass, you take the volume. Volume is 100 microliter, as you mentioned.
It's also 200 microliters.
So just multiply 100 microliters by this concentration. What will be the mass?
0.25.
Okay, it will be like 10 picograms. 10 picograms. 10 picograms is like very low amount. I'm not sure if it's possible to detect such amount of this compound by the MS detector. So did you use SIM mode?
In SIM mode.
Okay.
SIM mode.
Were there many ions of this compound at the mass spectrum?
Were there another ions? I didn't understand your question.
Were there many ions on the mass spectrum?
No, only fluoxypyrimethyl we obtained. Main ions, I know, but
Okay, so I personally
yes,
have
I
doubts
forgot.
that you can detect such amount, like 10 picograms, especially from the grape. I'm not sure if you can detect. So it's really something.
Since fluoxypyr, maybe it's with high affinity to fiber and detected with high peaks.
Is it possible to extract 100% of this compound by the fiber?
I guess no, because solid waste micro extraction, it's not exhaustive type. I guess like that.
Okay, thank you.
Okay. No more questions, dear colleagues? Is it efficient?
Саламатсыз ба?
А.
Бола ма маған?
Yeah, болады.
Можно на русском или на бәрібір ме?
Можно.
Ерғанат, так сіз тек қана 3 түрлі нені алыпсыз да виноградты? Мускитный там, Хусейн. Почему вы взяли только 3 типа винограда?
Саламатсыз ба, Балғасқымызға Лена, сұрағыңызға рахмет.
Тамасы.
Мен қазақша жауап бере берейін ба?
Мейлі.
Біз бірінші методта, яғни вакуумдық қатты фазалық микроэкстракцияны қолданған кезде біз 5 түрлі виноград таңдағанбыз. Өйткені ол кезде қалай айтсам болады, виноградтардың жалпы өсетін сезоны болды. Сол үшін көбірек виноград жинай алдық, және де біздің өзіміздің қолданған институттан виноградтардың түрін алуға мүмкіндік болды. Бірақ шағындалған қатты фазалық микроэкстракцияны қолданған кезде біз қалай айтсам болады, сезон емес кезде виноградтар өте аз болды, сондықтан тек қана 3 виноградты как реальный образец сияқты алған болатынбыз. Сол үшін 3
Бұларды сатып алдыңыздар ма? Сонда получается, вот мускат у нас же не растет, по-моему, этот вы, который зеленый, да, корейский, да, вы имеете в виду, да?
Иә.
Потому что екінші сұрағым насчет пестицидтармен бірге, тоже гербицидтар да бірге болуы мүмкін, фунгицидтар да кейде бірге қолдану мүмкін. Сіз ол қосылыстар шыққан жоқ па сізді GCMS-те? Гербицидтерді, тоже фунгицидтерді, которые использовали. Обычно екеуін кейде бірге қолданатын нелер болады ғой, мекемелер.
Иә, мекемелердің көбісі гербицидтерді қолданылады, бірақ басқа елдерде көп гербицид қолданылады. Және біздің алған пестицидтердің көбісі, 90% гербицидтер болып табылады. Яғни біз басқа фунгицидтерді қарастырмағанбыз.
Қарастырған жоқсыздар да?
Гербицидтер ғана.
Себебі қытайлықтардың өздерінің пестицидтары болады да, ондай нәрселер табылған жоқ па? Сіз литературамен салыстырған жоқсыз ба өзіңіздің неңізді? Данныйыңызда шыққан пестицидтерді? Обычно китайский пестицидтер отдельно обычно бывает.
Именно Қытай пестицидтерін салыстырмадық, бірақ осы күнге дейін жасалынған пестицидтердің көбісі, енді пестицидтер көп болғандықтан әртүрлі, бірақ именно біз қолданған пестицидтерді біз таба алмадық литературадан. Сондықтан виноградқа, яғни жүзімге көп қосылатын гербицидтерді таңдадық. Соларды анализдеген болатынбыз.
Сонда олардың мөлшері жеуге жарамды болып тұр ғой. Ондай көп емес, значит, пестицид.
Біздің алынған результат бойынша жарамды.
Рахмет.
Dear colleagues, if no more questions, the floor is given to the scientific supervisors. Мереке Бауыржановна Алимжанова, please.
Thank you. Good afternoon, dear committee members and dear colleagues. I would like to present a formal report of my recommendation on the doctoral work of Syrgabek Yerkanat. Over the course of 5 years, Yerkanat has demonstrated a high level of independence, responsibility, and scientific professionalism. All experimental work included in the dissertation was planned, performed, and analyzed by him independently. During his PhD studies, he published 7 papers in high-level international journals. 4 of which are directly related in the dissertation research. This publication reflects the depth, originality, and quality of his scientific contribution. Also, Yerkanat has also been active in the scientific community. Step by step, he expanded his participation in international, also high-level conference like XTEC, ICS, Evroanalysis, etc. In addition, Yerkanat took part in the 3 scientific research projects in Kazakhstan given by Ministry for Education, and also showed strong initiative in project development. He independently prepared and submitted a proposal for the Жазғалым postdoctoral project, won the competition, and currently in his second year of completing this postdoctoral program. He has also demonstrated excellent skills in preparing clear and well-structured scientific project reports. Yerkanat is a hardworking, motivated, and detail-oriented young researcher with a strong potential for further scientific growth. His dissertation fully meets the academic and methodological requirements for the PhD degree. Thank you very much.
Thank you, Melike Borjana. The floor is given to foreign supervisors, Pedro Antonio Garcia Encina.
Hi,
Please.
good afternoon.
Good afternoon.
Well, first of all, thank you for this option to speak about the work of Yerkanat, the PhD, during his PhD thesis. I think that Melike has done a very nice explanation about the work of Yerkanat, mainly because she has directly related with his work in Kazakhstan. But I have been involved in the supervision of Yerkanat when he was working in Spain. He spent some period of time in Spain. And I think that he is a very hard worker. He is also very, we can say, independently. He can take decisions in order to direct his research in the adequate line. For me, it's also very important to explicit that this thesis is not a common thesis or a normal, usual thesis, but is made by a compendium of articles. That means that the scientific quality of the work has been evaluated by peers. Then that means that it has a certain level of quality. And for me, it's very interesting to indicate that the Yerkanat has demonstrated deep knowledge in analytical chemistry and in the methodology development. He has done a comprehensive experimental work, including extraction, parameter extraction, validation, analytical validation, etc. And he has been actively involved in the preparation of this scientific publication. Then, from my point of view, I think that Yerkanat has reached the highest level for a PhD student, and as he has demonstrated during this presentation, is a very high level. Thank you.
Thank you. Thank you. And the floor is given to the first review, Marek Tabizevsky, PhD, Associated Professor, Gdansk University of Technology, Chemical Faculty, Department of Analytical Chemistry from Poland. Please.
Yes, thank you very much for the introduction. My opinion about the thesis is very positive. We have to pay attention that It is a series of papers, 4 papers, and they already have been assessed by international reviewers, by the experts in the field. In the 3 of these articles, PhD candidate is the first author. In the 4th one, he's the corresponding author. And we have to pay attention that the research has been financed by institutions in form of grants. So not only the research was appreciated by, but before the ideas proposed were appreciated. The results are novel. The 2 developed procedures, vacuum-assisted headspace SPME and mini headspace SPME, these are novel analytical tools for determination of pesticides in grapes. They have been developed. They have been optimized. Few parameters were optimized, and they have been validated. What is more? So definitely, I can see the novelty in the work of PhD candidate, and I can agree with the opinion of supervisor that I see potential in PhD candidate to be a good scientist and good researcher in the future. So thank you very much.
Thank you, Doctor. And the floor is given to the candidate to respond to the reviewer's comments.
Thank you, Dr. Marek, for your recommendations and comments, and well, positive voting. And I have no comments, and thank you.
Yeah, in fact, there are no comments. I have asked the questions during the questions session. So yes, thank you very much.
I have one question to, if possible, please. I just read. We just read your review, and here in the review, just a few moments. You said that the first provision is application level is medium. This is why you said it, and also I noticed that at third provision you said it's rather proven, while in the first and second provision you wrote proven. Why it was for the third provision you questioned that it's rather proven?
Yeah, this is because it was about the GAPI application. Yeah. And it is related to my question during the questions session that probably some more conclusions should be drawn based on this study. So actually, I got the response during the questions session, and now I'm pretty satisfied with the response.
Okay, thank you, Doctor. The floor is given to the second review, Maria Lampard, Professor, Center of Interdisciplinary Research in Environment and Technologies, Santiago de Compostela, from Spain. Please, Maria.
Thank you very much for inviting me to
You can tell us without details only.
Yes, of course.
Generally.
Summarize. I am going to read some aspects in my review form. Regarding the first point, the thesis, the study was conducted within the framework of grant funding for the scientific under the government of Republic of Kazakhstan. The second point, the importance for science, the work represents a significant contribution to science and society. This study advanced the understanding of vacuum and miniaturized head-space solid-phase microextraction for detecting pesticides in grapes. The methods were adapted for semi-volatile pesticides and evaluated using green analytical chemistry tools, providing sustainability and practicality. The optimized methods were implemented in a grape quality control lab, leading to a certified measurement procedure that enabled fast and eco-friendly pesticide analysis and support food safety and quality standards. Regarding point 3, the principle of independence, the self-reliance level is high. Regarding the literature data, the carrying experiments and the analyzing of pesticides in samples using GCMS after the sample preparation, but vacuum and miniaturized SPME, evaluation and interpretation of obtaining results, including deep validation of greenness and practicality. The principle of inert unit, the relevance of the thesis is well justified in the literature review. Indeed, the research conducted is no doubt important for science. All sections and provisions of the thesis are completely interconnected, and the solution proposed by the author are confirmed by research using modern methods of physical, chemical, spectral, experimental, and statistical analysis. Regarding scientific novelty principle, this is the first time that vacuum head-space solid-phase microextraction GCMS methodology is optimized for detecting 6 pesticides in grapes, defining key analytical characteristics. This is also the first time that mini head-space solid-phase microextraction GCMS is proposed for the analysis of 10 pesticides, including a fully parameter optimization as well as complete analytical performance evaluation. The environmental sustainability of both optimized methods and existing approaches was assessed using GAPI, AgriPreg, and BAGI, resulting in a unified greenness metric for pesticide analysis in grapes. It is also the first time of a study of these characteristics. The validity of the main findings was ensured, controlling testing conditions, analytical performance indicators such as detection limits, recoveries, linearity, accuracy, and reproducibility were conveniently evaluated, and measurements were performed in parallel experiments to guarantee statistical reliability. Regarding the main provisions for the defense, is the provision proven? Is proven for all of them? It is new, yes, all the provisions are new. The application level is high in all cases, is wide. It is proven in the article, yes. The provision is one of the provisions is at least proven in one article. The total number of articles is 4. Regarding the principle of reliability, the methodology is described in sufficient detail. The results of the thesis were obtained using modern methods like vacuum SPME, mini SPME, GCMS, as well as innovative metric tools. All important estimates are confirmed. the literature research is very complete. In fact, 2 review articles are included in this thesis, both in Q1 high-impact journals. Regarding point 9 practical value principle, the thesis has theoretical value. This study enhanced the understanding and application of vacuum headspace solid phase microextraction for quantitative pesticides analysis in grapes. Additionally, the greenness and the practical feasibility of the developed methods were rigorous, evaluating using GAPI, AgriPrep, and BAGI, supporting sustainable, transferable, and potential automated analytical approaches for complex food matrices. And regarding point 10, the quality of academic writing as well as design and presentation are excellent. And point 12, scientific level, the main results of the theme of the thesis are presented in 4 publications, all of them in international peer-reviewed journals with very high impact factor. 3 of them Q1 and only 1 Q2. And even the results were presented in 7 abstracts in international conference. Regarding point 13, the decision of the official reviewer, summarizing the consideration of scientific research, it should highlight the scientific quality and its practical significance. The work gives the impression of a complete scientific work with interesting scientific and practical conclusions, forming the basis for further research. All the tasks are solved in the thesis, thus in terms of its relevance, the volume of work, the scientific and practical significance, the thesis fully meets the requirements. The author deserves to award of the degree of Doctor of Philosophy or Doctor of Specialization. Thank you very much.
Thank you. Maria, the floor is given to the candidate to respond to the review of comments.
Thank you very much, Professor Maria, for detailed review of my thesis and for your question, and also your spending more time for reviewing my PhD thesis. And your questions and comments gives us possibility to improve our works mainly, and also will be helpful in the future research and development and other methods and findings, other directions. Thank you very much for your comments and questions. Thank you.
Thank you very much, Yerkanat. And congratulations.
Thank you, Dr. Maria. Dear colleagues, we proceed to the discussion of the dissertation.
Yeah, dear colleagues, we are now in discussion session. So any opinion, you are welcome to say. And please do not say how you will vote, okay? It's Professor Daniel Snow, Professor Solia. Yes, as an external member of our your opinion will be valuable.
So maybe I can start.
Please.
Thank you. So first of all, I would like to say that this is a very big thesis. A lot of results are obtained. Yeah, and as I know, these methods for food samples are quite difficult because of the complex matrix. Yeah, so a lot of compounds are present in grapes which can interfere with the analytes. And pesticides are also not very simple analytes. Yeah, so it makes the process of the development quite complicated. Yeah, so it's really nice that Yerkanat studied determination of pesticides by vacuum assisted solid phase microextraction. Yeah, which is also not easy to do, but I really like the results. But there were some comments from my side. Yeah, in my opinion, so in the future, probably Yerkanat should use more like theoretical calculations, maybe some modeling, just to better understand and explain the results, yeah, and better plan the experiments. Yeah, but now we have quite solid experimental research with a lot of results published in a very good journals. Yeah, like highly ranked journals. Yeah, and in my opinion, all the principles are fulfilled for the defense. Yeah, from the requirements for PhD degree. Yeah, and I think that all comments can be addressed in the future by Yerkanat. Yeah, and so it's really a good thesis. So in my opinion, so I just I will not tell how I will vote because we have a secret poll. Yeah, so thank you. That's all from me.
Thank you. Please, dear colleagues.
Maybe I'll go next.
Yes, please.
Yes. I think candidate has done a lot of method development work, and it's commendable, especially commendable that he already has several publications. I think that is one of the biggest challenges for a PhD student is to get publications out and in the literature, and this is quite remarkable in my opinion. The process, the analytical process was well documented. The figures of merit properly addressed in the publications, and I think the work is quite suitable for a PhD. So those are my comments.
Thank you, Doctor. Please.
Can I comment as well? I just went to Pop Science and I really appreciated the results of its candidate of Syrgabek. I don't know if you noticed the two papers are from the four papers he presented. In our country, it's usual to have at minimum is 4 papers together, and then the student do not need to write the thesis as a usual way, but just present 4 papers and comment them. From 4 papers, he has 2 papers which are not only Q1, they are in D1. Actually, one is the best journal in analytical chemistry, and the second is also in D1 in analytical chemistry, the advances of some preparation. And the D1 journal to publish for the PhD students as a first author, and he's in 2 D1 journals. The first author, one is review, one is experimental work. It's something which is counted very, very positively. And I have to congratulate to him for these results. And of course, it's not only result of the student, also the result of the supervisors and the group, research group. So in my opinion, the publications which were accepted in such highly cited and highly evaluated journals, D1 journals. It's something which he has to be proud for this. That's my comment.
Thank you, Doctor.
I will also comment, but probably a little bit, how to say, not problems, but not with so happiness, let's say. The problem is that we are giving the PhD in field of chemistry. And what I want probably for a future candidate to see what is the chemistry behind all this process, because you can't do analytical chemistry without understanding chemistry. Yeah, what is the base? What is the? That's my question was like if candidate knows this is let's say base of chemistry. This is only my suggestion for future candidate who will defend on analytical chemistry field. But the second one is more positive. Yeah, I'm also happy with the candidate because now we see expert in not the analytical chemistry of grape, but also analytical chemistry at let's say at more than we see how he can manage with many things. Also, we saw the presentation, which is really accurate. So the presentation accurately done, which is also quite good. And the publication, as Professor Petr Soleh mentioned, yeah, I didn't check all these the citation, but I know that this journal is a quite well-known journal. Yeah, so I also, in general, I happy with the candidate. I mean, with the how he defend his results. But as I said once again, with this suggestion, to improve, to develop in the future. So thank you.
Thank you, Bulat Patrovich. Okay, a break, dear colleagues, a break is announced for the secret ballot.
Так, Булат Нурланович уже. Булат Нурланович, вы проведете, да, пожалуйста?
Да, я проведу. Okay, so we move everybody except the members of the dissertation council and reviewers to the waiting room.
Булат Нурланович, сейчас Ахмед Мухаметов подключится.
Да.
Вот.
Recording in progress.
So now we have like 11. How much should we have? Okay, one supervisor. Should be moved to the waiting room. Okay, so now we have 9 people. Just a second, I need to start the poll.
Excuse me. I don't know how where I can to leave my vote.
Okay, dear Maria, I'm just launching, so I haven't launched it yet. So now you will see on the screen the question. Okay, so now please vote for one of 3 possible decisions.
Thank you. Yes.
Thank you.
Thank you very much.
Okay, the secret poll has finished, so we have 9 votes. So now I can show to everybody, but probably I will return everybody from the waiting room, just so that everybody will see. Akmara Muhambetovna.
Yes, I'm here.
Okay, so should I open the results?
Yes, I asked the members of the dissertation council to approve the voting protocol, and according the voting results, 100 based on the defense and the results of secret online voting, the dissertation council at Al-Farabi Kazakh National University awards the degree of Doctor of Philosophy PhD to Syrgabek Yerkanat for the dissertation on the topic development of methods for the determination of pesticides in grapes using solid phase mixture extraction on specialty 6D05301 chemistry.
Oh, congratulations. Thank you for all members. Yeah, to candidate Yerkanat. Thank you for reviewers, for external council member. Thank you for your time. Yeah.
Thank you all for participating in the defense.
Thank you.
Congratulations. Yerkanat құттықтаймын.
Thank you.
And
Thank you.
congratulations.
Thank you.
Congratulations.
Congratulations.
Congratulations, great work.